Scientific notation is a method for writing either very large numbers or very small numbers in a compact form. For example, a light year is the distance that light will travel in 1 year. 1 light year is approximately 946 quadrillion centimeters. 946 quadrillion has 15 zeros and can be written in scientific notation as 9.46 times 10 to the 17th power. Scientific notation is the method of writing a number in the form a times 10 raised to the n power, where a is a number greater than or equal to 1 but less than 10, and n is an integer. In the example shown, the value for a is 9.46, and the value for n is 17. The exponent 17 indicates that the decimal point would need to be moved 17 places to the right. The mass of a neutron is approximately 1.675 times 10 to the power of negative 24 grams. This can be written in standard form by moving the decimal point 24 places to the left. When you multiply numbers written in scientific notation, you should multiply the coefficients and then multiply the powers of 10 by applying the product rule of exponents. In example 1, 3 times 10 to the 4th power times 2 times 10 to the 6th power can be rewritten so that the coefficients 3 times 2 are multiplied, and so that the powers of 10, 10 to the 4th and 10 to the 6th are multiplied. 3 times 2 is 6. 10 to the 4th times 10 to the 6th is 10 to the 10th. Remember to add the exponents. In example 2, multiply negative 6.2 times 10 to the 6th power and 5.3 times 10 to the negative 3. Multiply the coefficients. Negative 6.2 times 5.3 is negative 32.86. Multiply the powers of 10 by adding exponents. 10 to the 6th power times 10 to the negative 3 is 10 raised to the 3rd power. The result, negative 32.86 times 10 to the 3rd, is not written in scientific notation since the absolute value of the coefficient 32.86 is more than 10. Since 32.86 is equivalent to 3.286 times 10 to the 1st, the 10 to the 1st is multiplied by 10 to the 3rd to get 10 to the 4th power. When you divide numbers written in scientific notation, you should divide the coefficients and then divide the powers of 10 by applying the quotient rule of exponents. In example 3, 9 times 10 to the 12th power divided by 3 times 10 to the negative 4th power can be rewritten so that the coefficients are divided, 9 divided by 3, and so that the powers of 10 are divided, 10 to the 12th power divided by 10 to the negative 4th. To divide the powers of 10, remember to subtract the exponents. 12 minus negative 4 is the same as 12 plus 4, or 16. So 9 times 10 to the 12th power divided by 3 times 10 to the negative 4th power is 3 times 10 to the 16th power. In example 4, divide 2.4 times 10 to the negative 4th power by 3.6 times 10 raised to the 7th, and round the answer to 1 decimal place. Divide the coefficients. 2.4 divided by 3.6 is 0.6666, with the 6 repeating. Divide the powers of 10 by subtracting exponents. 10 raised to the negative 4th power divided by 10 raised to the 7th is 10 raised to the negative 4 minus 7, or 10 raised to the negative 11th power. The result, 0.66666 times 10 to the negative 11, is not written in scientific notation since the absolute value of the coefficient, 0.666666, is less than 1. 0.666666 is equivalent to 6.66666 times 10 to the negative 1 power. The 10 raised to the negative 1 is multiplied by 10 raised to the negative 11 to get 10 raised to the negative 12. Then rounding the coefficient to 1 decimal place gives us 6.7 times 10 raised to the negative 12. Try to self-check at the bottom of the page.